Welcome, everyone. Excuse me if I have a bit of a sore throat. I actually realized when I went here, I think it was the same case last time I presented at Øredev. So I blame the season of the year. I hope my voice lasts the entire session. If not, we'll have to just skip through the slides. My name is Emil Kvarnhammar. I work for a startup, or I'm a co-founder of a startup named Oplane. And we work with, we try to solve the puzzle of security by design by using large language models. So I'm going to talk a lot about large language models and how you could utilize that for analyzing code and building diagrams automatically. And also a lot more cool stuff, of course. One thing else I'm going to talk about is Labradors. You might wonder what Labradors have in common with large language models. Maybe you already know, but yeah, at least I thought it would be fun to share. Maybe an unexpected part of this presentation. So first of all, about security by design and the problem we're trying to solve. We know that the foundation of security by design is to understand and have an accurate view of your software architecture, both within a software system, but also between different software systems, for instance, in a larger enterprise. This is the foundation to understand the critical security risks that you should prioritize to solve. Because it depends a lot on the context. The context is in the architecture design, right? So that's not, the context and the architecture design, that's not really a security problem. And you are developers, so you know all about that already. An obvious challenge with design is that the architecture changes continuously, both within the system, but also towards in the integrations towards other systems. So some people think that, of course, parts of this already lies in the cloud infrastructure or in infrastructure as code. Why don't you just use that? Yeah, we considered using that, but we think that it lacks a lot of details that we'll find only in the software produced. And I'm going to talk a little bit more about some examples of that. So why is this a problem that we need to solve? We think that, or we actually talked to 40 plus organizations around the world. We've talked to people in the tech industry, people in financial, different sizes of companies, both developers and security experts. We talked to CISOs, CTOs, to understand people's various perspective on security in software development. And the conclusion was that most of the people we talked to, they value threat modeling a lot. Even if they only came across it once or twice, they thought that there was a high value in the output produced. But one of the main challenges is, or two of the main challenges is that we need time. We need expertise to some degree to understand how to do a good threat model. And since most of these steps needs to be done manually in threat modeling, it takes a lot of time. And especially if we want to keep it up to date continuously as our software grows. So the obvious question became, how can this be automated? And if so, how? And if you had asked me about like 2-3 years ago, I would probably have said, no, this is not going to be possible to automate. Because this depends completely on the collaboration between the development team and the security team in order to produce a successful threat model. That's where you get the actual value out of it. And the people we talked to in the interviews, they agreed to this more or less. So we dig deeper into this, and because we believe in the meeting between developers and security, we also think that threat modeling, when done right, is the ideal meeting spot for developers and security to talk about security by design. And it's also the opposite. It's extremely difficult to find more effective ways to achieve security by design if it's not done through threat modeling. But again, time and expertise is the main challenge. And even if organizations have security expertise within their own company, they're occupied with a lot of other important stuff. So security managers, they ideally wanted to roll out threat modeling to a larger degree, but they failed in prioritizing it because of firefighting in detection and response and so forth. Still, we're convinced that it's the right thing to do longer term to achieve robust and secure software. I usually describe threat modeling in 3 simple steps. You probably heard about, if you have done threat modeling before, you probably heard about the 4 questions frame. What are we working on? What can go wrong? What are we doing about it? And did we do a good job? It basically means the same thing as this, it's just 3 instead of 4. And I like when it's simple. So the first step, architecture modeling. Without a good understanding of the architecture, it's more or less impossible to understand what the relevant threats are. So each of these steps are strictly dependent on the quality of the previous one. Same goes with implementing countermeasures. You can't start with implementing countermeasures, right? You first need to understand what you're trying to mitigate or the problem you're trying to solve. And in order to understand the threats you're trying to mitigate, then you need to understand the architecture. Plain and simple, right? So, architecture diagrams. Who of you here have accurate architecture diagrams of the software you are building today? A few. So why isn't anyone creating diagrams anymore? It's boring. And it's not useful? It's changing? You use whiteboard instead when you introduce new people to the team? I recognize that. And there's nothing wrong with that, right? But it's also a bit biased, I guess, depending on who's drawing on the whiteboard and for whom. And that's also extremely important to remember when we try to do an effective and accurate threat modeling. Then the security people, they have a cognitive load to understand the software you're producing because they are not software experts, right? And that's why it's so important to try to achieve a consistent format with the right level of details. If we look a little bit closer at what a software diagram consists of, it's the applications, right? And we have some different data sources. We might have external services like OpenAI in this example. But it's also the relationships between these components. In most cases, it's relevant to understand not only the fact that OpenAI is used, but from what component or from what microservice it's used. This is from an eShop reference application for .NET, where they want to promote certain architecture patterns. And they use that by supplying this as a reference application. And the diagram actually comes from the repo of the eShop reference application. Do you think it's up to date? Probably not. There are some changes to be made to the code, even in a reference application, since they produced this diagram. But we don't need to bother about that today. The important thing to remember here is that there are certain things that the diagram consists of, and that information is crucial whether we want to produce this diagram manually on the whiteboard or in an automated way. I already talked about the main challenges when doing this manually. Time, of course, and time is valuable. And keeping the diagrams up to date, because it's frustrating and it's pointless to do diagrams if it's outdated 3 months after, especially in larger enterprise organizations. I think that if you walk into a larger enterprise company, no names mentioned, but if you walk into that type of organization and ask an enterprise architect, show me how the software works in this company, they might be able to show you a diagram, but I doubt that that diagram is accurate. If you take that diagram and go to a developer team and say, hey, where in this diagram are you guys? They probably won't have a clue. I suspect at least that that type of diagram is going to be fluffy, and if it is accurate, it's at the fluffiest level so that no one recognizes where their piece of software fits in. So it's also important to try to achieve a consistent format, and especially again for security analysis, it's even more important. If we want to do security analysis effectively in multiple software teams, then ideally we would have the same format of diagrams in all the teams. And of course, that can be done in a standardized way to some degree if you promote a certain way to draw your diagrams. But even if you do, let's say that you use C4 or data flow diagrams of some kind, then you'll still have discrepancies between the teams. And that causes difficulties when doing a threat model. So we wanted to try if we could generate diagrams using LLMs. And we talked about diagrams as code as one option. But the obvious challenge when creating diagrams as code with LLMs is that we still need some input data. Of course, you could create diagrams as code using a prompt, but that is basically just using a different syntax compared to Mermaid, for instance. So if you want to produce custom diagrams in your preferable format, then you need to first find the input data needed. We chose the way to find that from code because there are no other good ways, in my opinion. You could consider extracting it from documentation, but hey, who writes documentation and who keeps it up to date? But you keep the code up to date, right? You have to. And if you don't, then the diagram is still accurate. And the way we have approached this is basically to prompt in multiple passes and use the output of the prompts and combine them, the outputs, in code, and then do other prompting, subsequent prompts on prompt results, and so forth. And that works, actually. But first of all, I'm going to talk a bit more about diagrams as code prompt. So if we want to produce a diagram like this, we can, of course, instruct the LLM to generate a MEMA diagram with the following applications: Identity API, Catalog API, Basket API, blah, 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 all the microservices in the eShop reference application. And of course, we also need to instruct it to set a connection between the services that should have a connection. The event bus, place that into the picture, and a Postgres database, for each of the services that should have a Postgres database. And finally, the Redis cache for the basket API. Yep, that definitely works. But again, we haven't solved the actual problem. Because in this case, I actually cheated. I took the information that I needed for the prompt from the diagram. So that relies on having the diagram in the first place, and that is up to date. But if we have the information, we can do it with Mermaid or a custom format or what have you. So what was the actual problem again? We need to keep it accurate and up to date with the right level of details in a consistent format. The best part, and it's not only good parts with LLMs, I should emphasize that. You probably know this already if you tried GPT-4 or something similar. But one of the best parts is that it's program language agnostic. And believe me, I've done a lot of security code analysis before in my career. Some programming languages I've learned by doing code analysis and code reviews, at least learned to some degree. But I will never outperform an LLM in understanding whether it's Kotlin, Erlang, Java, Scala, what have you. This is what the model is good at. It can also process a lot of data. It can systematically map certain parts of the architecture with relevant security design practices and security implementation. And maybe the most important thing, it's a lot more scalable than I am. So if we could achieve something similar with an LLM, then we have a scalable way to solve security by design. And this is what everyone is looking for, that we talk to in the interviews I mentioned. Because at least the tools that they have evaluated, they're still completely dependent on that a human expert facilitates the threat modeling in one way or another. So how do we go ahead when we mine data for the diagrams with LLMs? First of all, we learned that it's very important to be explicit. And that might sound like an easy thing. Hey, just be clear with what you want and then the LLM will figure it out. But that can be extremely challenging in some cases. But one way to simplify for the LLM is to use a defined output format and specify the output format that you want for the LLM. And ideally, specify some examples. And examples should be driven by what you've seen when you analyze different kinds of source code, in this case. But the same goes if you would analyze medical journals, I assume. Then it's still important to have examples so that the LLM can easily understand how you prefer this data to be sorted and attributed. If you don't, then you typically get hallucinations. And the bigger your prompts get, the easier it is to accidentally introduce contradictions in your instructions in the prompt. So that's also a big caveat with this. This is, I'm not going to talk about our diagramming format, but this is just a snapshot to show that if you have the mined data you need, then you can basically render it in any way you like. So this is just for demoing purposes to show that we can render the same diagram as they manually produced for the eShop reference application. One of the biggest benefits is that even if, well, we are not really UX experts, but the biggest is that we have solved all these 4 bullets. We generate this in minutes instead of taking at least an hour together with the team to draw the diagram. It's by design up to date since it's generated from code with the right level of details in a consistent format. But again, consistency in data, consistent format is one thing, but getting consistency out of the LLM, that's a completely different challenge. And to get correct data out of the LLM, and correct can be a bit subjective depending on the context. I'm going to show an example of that fairly soon. And if you have experimented with prompting, you might have seen this in other use cases, that you can get, like, if you ask the same thing 5, 6 times, you could get a different result the 6th time. And that's usually goes back to that the instructions are not crisp and clear. So there are ways to solve that as well. There are also limitations, different limitations depending on the model you use, but you have limitations in the max amount of tokens you can send to the LLM and retrieve from the LLM in the same prompt. Because otherwise we could as well just send all the code at once and ask it to produce a diagram. Do you think it would be a good strategy in doing so? Hey, here's my code, generate the diagram. I wish it was that simple. But the big challenge, as with any LLM implementation, is that you need to understand what to filter out and what to sort out. And the information that matters and what information that's just noise. And that's also because of performance and throughput and cost reasons. Performance and throughput has become less of a problem than it was like 6 months ago. So we have prompts now that take 1 or 2 seconds that used to take 25, 30 seconds on previous models. So it's definitely been improvement in models for instance, in comparison between GPT-4 and GPT-4o, and there's more coming. But yeah, you still need to consider that you can't utilize the LLM. If you use it as a service, at least you can't utilize it as an infinite resource. And even if you deploy it on your own custom hardware, then still the same problem. So in this example, let's say that I have this simple piece of code with the onInit method, and that's calling another method, read Postgres credentials from settings. And in this case, let's say that that's not part of the same file. Maybe it's an inherited method. What do you think would be the response on this? If I ask it to generate a JSON list of all databases used in this source code. Zero items, 1 item, 4 items. It actually answers that this contains Postgres. And I'm a bit doubtful because it only says read Postgres credentials from settings. So that indicates that Postgres is used in one way or another. But there's no proof here in this simple piece of code. Then you might think that if you only want actual database usage, then why not be more explicit? Why not just give more details, instructions in the prompt? I'm going to talk later about categorization, which we found that to be a lot more powerful strategy compared to being detailed. So one thing you could try is to ask the LLM to provide a motivation. Because I don't understand why you consider this being Postgres use. So for each database found, I want you to return a motivation that describes how the database is being used. And then it says that the database is used for managing application data. Specific operations or purposes are not clear from the provided snippet. Yeah, no shit. And now we're touching upon what LLMs and Labradors have in common as a bit of a teaser. I'm getting back to that later. Categorization. Let's pretend, or let's imagine that we try to set an additional attribute because the motivation indicated that it doesn't really know if Postgres is being used or not, but it still responded that there is Postgres. So let's try to ask it to set a type of use as well. And we defined 3 different types of use in this case: CRUD, configuration, implied or suggested. What do you think it answers then? Good. Sorry? Yeah, I can send one to you. Yeah, it's a bit surprising that you guessed right. Maybe you experimented with this, but I believe there's a reason behind this, and my theory at least is that I didn't drill deeper into why it responds configuration, but my theory is that it still believes that the context of the database used is for configuration, or that it somehow relates to configuration that's needed to connect to the database. But that's not really what I want. And you know why? Because if I wanted to mine out data to create a diagram, then configuration related to a database, that can be extremely valuable. That can be a connection string, for instance, so that I can name my database instance with the exact name that you have in the connection string, for instance. So I don't want to filter out configuration. The next thing to try is to describe what we actually mean with these different types of use. And I'm going to take a shortcut here. I'm only going to describe what I mean with implied or suggested, because I think that that's what the LLM actually does. It considers that the code implies that a database is being used, rather than seeing it as configuration or CRUD. And guess what? Then it responds implied or suggested. And now I've been explicit with what categories I want and what the different categories mean, or at least what implied or suggested mean. The response wouldn't be different if I had lined up what configuration means and what CRUD means. I might be able to solve this the other way around by describing what CRUD and configuration is and not saying anything about the implied or suggested, because it can still understand what I mean with that type. But the best part with this is that I could have spent hours in trying to tweak this prompt in many different ways to produce an accurate result. And if I wanted this piece of code to not produce any findings related to databases, then that can be more or less an impossible challenge if we don't use categorization. But if we make it categorize the Postgres database as implied or suggested, we can filter that out in code. So if we get such responses, we just decide to ignore implied or suggested, or at least save them and see for QA purposes to ensure that this isn't actual database usage. Step 2, identifying threats. This is a well-suited problem for LLMs, but the same goes here. You need to focus on the context. You can try to make the LLM improvise or using examples, but the input data you give matters a lot. So just to show a simple illustration of where LLMs can misunderstand you as well. With identifying threats, if you tell it to list all threats with severity, you could get something like this. 3 different threats. One is high, one is medium, one is critical. Let's say that I want to filter out to only show the high and the critical. What do you think the LLM does? T-shirt. Yeah. That's a good guess. It's the will to please. And now we're getting to the Labradors. Labradors can solve tasks you can't. I firmly believe that. This is my dog, by the way. They're extremely easy to train, probably because they love food. Maybe that's not what LLMs have in common. Their will to please. That's my point here. They'll do everything to please you. And if they return inaccurate results and you ask it, why did you return that as part of your result? That's incorrect. Oh, I'm sorry. Here's the correct result. Yeah, but why did you return the wrong result? That's more or less impossible question to ask it. It would just, oh, I apologize. Here's the correct result. If they don't understand, it's most likely because of you. So think about that when you read about LLMs and hallucinations and so forth. It's probably because of bad prompting. If you guys disagree, I would love to talk about that. But that's my impression as well. So let's say that we want to list the threats based on the Mermaid code as input. If we were to go the Mermaid route, that actually works, but you'll get a holistic result saying basically what you have in the OWASP top 10, more or less, or in OWASP proactive controls or other security by design best practices. So this isn't really like context driven enough. So it's not easy to grasp because you could more or less give this as an example list to a development team. And they will have difficulties in digesting this. Speaking about cognitive load, this is high cognitive load for development teams to understand. We can do the same with the eShop diagram. Hey, what security threats do you see in this picture? And it will do more or less the same thing. It will have some degree of context, as you can see. There are names of services, identity, catalog, ordering, names of databases. You can see that it uses Postgres databases. What if we try to add a use case to it? I want the security threats relevant to add to basket. One of the services is Basket API here in the middle. Do you think the LLM will understand what we mean? The problem is that even if you tell it to focus on add to basket, there's not enough information provided to the LLM that the use case add to basket is actually implemented in the Basket API application. This is something the LLM might be able to guess based on the naming convention or the naming of services. But that's a bold assumption, depending on what type of architecture you have in your software, because there's no guarantee that the use cases will have similar naming conventions as the actual services implementing them. So this will produce similar results. And with the add to basket case that focuses solely on the basket API application, there is no SQL database in the basket service. But it still says that the relevant threat is when malicious users might attempt to execute SQL. If we ask it to return threats related to add to basket implemented in basket service, basically narrowing down the context to that piece of code. Still only looking at the diagrams, remember. So the only thing we provide to the LLM is the diagram. Then it's getting a bit better. The SQL stuff is gone, so there's no mention about Postgres anymore. And this is a bit easier to grasp, but it's still based on the picture. So how do we know where the use case is implemented? Because it's less useful if we don't. So what we do is we first map the architecture model together. And since we have the architecture model, we know what each microservice exposes in terms of interfaces and APIs, and what interfaces it uses on other applications or APIs. And then it's an easier thing to do to extract what are the relevant use cases and data flows out of that, both within a single application and across different applications. So, some conclusions on the threat part. It depends a lot on what information you get into the identification of threats. Same, again, as the manual way of doing threat modeling. If you don't have enough details when doing manual threat modeling, the same goes for that. You will get brief recommendations, holistic recommendations on what you can do and what's relevant in your case. The more you narrow down the context, the more useful output it gets, and the more robust security by design. This also means that we can reduce the need of experts. We are targeting to eliminate the need of experts. And finally, the last step, implementing countermeasures. Once we have pinpointed the threats, and if we provide code context and more data to the LLM, then it's actually quite good at recommendations of code changes. And of course, this also depends a little bit on the input needed, because there might be architecture best practices that you would like to utilize in your organization. There might also be additional considerations from a security threat perspective that needs to be part of producing a robust countermeasure. And of course, there's a usability and the performance impact that's a bit more difficult for the LLM to understand. But about the actual implementation, I don't know what you guys think. Would you be fine with an LLM generating a PR for you? Saying, if you just merge this, then the threat is automatically mitigated. Because then you wouldn't need to be involved in threat modeling at all. Then it would just be something spinning in your pipeline, generating a PR. Maybe not. Good point. So we need to tie it to the threat model in some kind, so that if you can understand the context, then you might be comfortable in merging this and comparing like what problem it's trying to solve. At least you need to be an expert in the code. But in the security, it depends to what degree you trust the LLM to have produced an accurate countermeasure that actually solves the problem. But at least we are not completely done with this part yet. We are working on that right now at the moment. But what we have learned so far is that it's usually outperforming humans in producing better, producing a good countermeasure. And I say usually, it depends a little bit on what type of threat. But one thing it can do is that, of course, it has a lot of information about like best practices in frameworks and things like that. So, of course, there's a time factor to this as well. If human beings would try to solve this like in a team, spending 8 hours each, then maybe it would be a better result. Considerations of your context and your architecture. But that time is valuable, right? So at least producing countermeasures to the relevant threats based on the relevant architecture model, that's a problem that's solvable. The question is to what degree we can tweak it to fit into each code change. But I think that even if we were just to produce recommended code snippets, then that would still serve a value. The most important is that you have a list of threats and things to consider when implementing your countermeasure. Then I'm sure that most development teams would be comfortable with creating that countermeasure manually. That still saved a lot of time in the other steps. So you have seen that, or at least what we believe is important at Oplane is that all of these 3 steps need to be tied into the actual code. Because it's difficult if you only produce the architecture model in what diagram format you prefer, and then you try to identify the threats by connecting to code. Then you don't have the relationship with the architecture model. And then it becomes extremely difficult to understand what the relevant threats are. Then you basically have static code analysis. And I guess people who have tried static code analysis knows that there's a high degree of false positives. And the main reason for that is that static code analysis are incapable of understanding the architectural context and understanding in what context this might be vulnerable or might not be vulnerable. Any questions? Has anyone tried talking to LLMs about code, like finding security vulnerabilities in code? Is it good at it? Yeah. Yeah, exactly. Definitely. Yeah, that's a really good question, because that's one of the foundational aspects why we think that going the code route is definitely the only sustainable way. Because with the assumption that code will get automatically generated in the future, then we need this even more. We need to model it automatically as well, because I mean, we're already at the place where even if it's created by human beings, the code, we still can't keep up to pace with doing security by design. At least few organizations can. There are some exceptions, at least what they claim to in finance, defense industry, but even there, I think that there are things that get down prioritized. But we might come to a place where, of course, it would be good if that code that is automatically generated is secure by design out of the box. But from what we have experimented so far, it's not. Any more questions?
Would you monitor the security like on the answer the LLM is, for example, on the account level?
Yeah. Who tests the experts? Yeah. 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 That's one of the biggest challenges with recommended countermeasures. That in some cases it's very crisp and clear, and sometimes it's based on some example that it found somewhere that it's no longer relevant. But it can still lead the way to some degree. Yep. All right. So guess that's it. Thank you very much for listening.